So quadratic equations are a kind of, linear equation. It's a equality, but the variable we have has a power. Like if a linear equation was like x equal ax plus b, now quadratic equation will be something in this form with a power for x. So we are going to work on this kind of linear equation. Quadratic equation in this chapter. And how we can, find answer for x, how we can use, actually previous chapter we were using factoring to factor this kind of quadratic equation and solve for x. In this chapter we are going to use different methods to solve this kind of quadratic equations. Okay. So the first method we are going to use is this, the square root property. So for example, if we have such an equation like x squared minus 36 equals 0, we can rearrange this and write down x squared equal to 36 and solve this for x. Now the way we solve this for x is called the square root property. Like if we have x squared equal a, x can be two answers, either positive number or negative number. And this number would be a square root of a. So if I want to show you how this works, let's say we have 9 equal a. Correct? So this 9 could be two numbers, positive, negative, 3 power 2. Right? So a would be a square root of positive, negative 3, the index is 2. And as you know, these two will cancel, right? If the power and the index is the same. So a could be positive, negative 3. So these are all properties of a square root, power. So in this way we are going to solve some quadratic function which has just one variable, x, and that variable has just one power, which is power 2. So as you see, we don't have something like this, x squared plus x minus 36. So there is not any single x with power 1. That's why we can use this property. Okay, so if we want to solve this using this relation, we will write down x is equal to a square root of 36 with a plus and minus sign. So what is the square root of 36? 6. So answer will be plus minus 6. So there is just one thing about this kind of, solution. We have to check them. We have to check our answer. So how we check them? We put back them in equation. So if we have x squared minus 36, one time for x we put 6, another time for x we put negative 6, right? So let's solve this for x equal positive 6. So we will have 6 power 2 minus 36 equals 0, which is 36 minus 36, which is equal to 0, right? So this is correct. So this answer is correct. Then if we want to check for other one, negative 6, we write down x squared, x equal negative 6, and then for x we put negative 6 power 2 minus 36 equals 0. 6 power 2 is 36. Actually negative 6 power 2 is 36. So we get rid of this negative sign because it's a power. Minus 36 equal 0. 0 is equal to 0. So this answer is correct. So we checked our answers and both of our answers are correct. The other example has some more numbers. In order to use this property, we have to isolate x squared one side. Okay, for example, if we have 3x squared plus 2 equals 77, so the first thing we should isolate x squared on one side, right? So what we do, bring these 2 to the other side. So we will have 3x squared equal to 77 minus 2. Three x squared is equal to 75. Can we divide 75 by 3? Yes, because 7 plus 5 is 12. 12 can be divided by 3. So divide both sides by 3. We will have 25. So now x squared is 25. What is x? 5. 5 plus and minus 5, right? Plus and minus 5. If we use that property, square root property, we will have plus and minus 5.
How do you know where to put the plus and minus? Like if it's outside the square root or like inside of it?
Outside of the square root.
Like you say 36.
So look at this. We are just following this rule. So if x squared is equal a, x is plus minus outside of the square root, right? So the rule says plus minus is outside of the square root. So x squared is 5, x is plus minus square root of 25, which is 5. So let's check them. One time, check for x equal positive 5. Another time, let's check for negative 5. Okay, so we put this back in this equation, right? So 3 positive 5 power 2 plus 2 equals 77. 3 multiplies to 25 plus 2 equals to 77. 75 plus 2 is 77. 77 is equal to 77. So 5 was correct. Right? Now we'll check negative 5. 3 multiplies to negative 5. Power 2 plus 2 is 77. Negative 5 power 2 is 25, right? 3 multiplies to 25 plus 2 is 77. 75 plus 2 is 77. 77 is equal to 77. So both sides are equal. Okay. The next question says if we have x squared equal to 48. So again we use the rule. X is equal to plus minus a square root of 48. So now we should solve this and simplify this. So 48 is 2 multiplies to 24, right? So 48 is 2 multiplies to 24. 2 multiplies to 2 multiplies to 12. 2 multiplies to 2 multiplies to 2 multiplies to 6. 2, 2, 2, another 2, 3, right? So it will be 4 times, we are multiplying 2, multiplies to 3. Or we could write down 4 multiply 3, because now here I can write down 4 multiplies to 4 multiplies to 3, right? Which is 4 power 2. And then I know the index is 2. So if index is 2, power for this 4 is 2, I can bring out 4, but 3 stays inside the radical. So now if you want to check it, okay, so they already checked it. They didn't check. Okay. So actually, that's why it doesn't check that. So let's put 4 radical 3 in here. It should be equal to 48. So what we have, 16 multiplies to 3. If we have radical 3 power 2, if we have 4 power 2. This one is 4 power 2, this one is radical 3 power 2. So this should give us 48, which is correct. Then if we want to check for a negative 4 radical 3, again we do the same thing. Negative power 2 is positive, 4 power 2 is 16, radical 3 power 2 is 3, equal to 48. So both of these answers are correct. The other question says, okay, let's solve this. So I said we should isolate x squared on one side, right? So here we have 4x squared. We should make it x squared equal to something. So we have x squared equals 16 over negative 4 because I wanted to get rid of this 4 here. So we have x squared equal to negative 4. So if you want to follow this, we will have x equal to plus minus radical. Imagine this whole thing is a. Correct? The whole thing goes on the radical. So on the radical we have negative 4. But now we know how to solve this kind of radical. Indexes. Even we have negative number. Before we learn about imaginary number, we would say the answer is not a real number, right? But now we can use imaginary numbers. So we'll write down x equal to plus minus radical negative 1 multiplies to 4. And then x equal to plus minus radical negative 1 multiplies to radical 4. So what is radical negative 1? Correct? So we will write down x is equal to positive minus positive negative I multiplies radical 4 is 2, right? So let's bring it here to write down 2i plus minus 2i. And then they are trying to check their answer. So they will put positive 2i for x, then they will write down negative 2i for this x, okay? And then 2i power 2 is 4i power 2. Here negative 2i power 2 is 4i power 2. So the same thing. 4 multiply 4 is 16, but I squared was, do you remember what was I squared? So if I is radical negative 1, I squared is negative 1. That's why they have now negative 4 here. So negative 4 multiplied 4 is negative 16. And it will be the same on both sides. Okay, so now we have 4x minus 1 power 2 equal to 5. Okay, so here we have x squared equal 8, right? We could say parenthesis square, whatever could be inside the parenthesis, is equal to a, and that says parenthesis means whatever we had inside the parenthesis is equal to positive, negative a. So this whole parenthesis, imagine it was x. It says x squared is equal to a. So x is equal to plus minus radical 5. Correct? So whatever we have inside the parenthesis can come out without a square, and it will be equal to positive, negative radical of whatever we have on the right hand side. So whatever we have inside the parenthesis, 4x minus 1, is equal to positive, negative radical 5. Or if it is difficult for you to understand, you can write down, okay, this whole thing was u squared is equal to a, u is equal to plus minus radical a. What is u? U is 4x minus 1, correct? Is equal to plus minus radical a, which is 5. So this one is a. Correct? So now we can solve this. Solve for x. 4x is equal to 1 goes to the other side, becomes positive 1 plus minus radical 5. And then what? We should isolate x, right? So divide both sides by 4.
And that would be our
Actually, so if we keep the positive, 1 plus radical 5 divided by 4, right? If we want a negative, 1 minus radical 5 divided by 4. So we have two answers for x. One is with a positive, another with negative. Do you have any question? So this was one of the methods to solve quadratic equation. Another method, we call that completing the square. Completing the square. Okay, I will start with something that we had in past. So what we had a plus b or minus b power 2 equal to a squared plus and minus 2ab plus plus b squared. If we have x squared minus 10x plus 25, it means we have this side of this equality, and we can make it like this, which we call that complete square. So here for us, a is x, b is 5, because this is b squared, right? This is a squared. plus minus 2ab. Let's see if this one works. 2 times a multiplies to b gives us 10x, right? If I have a negative sign, means I was using a minus b power 2. So this one is a minus b power 2. That's why we have negative sign between. So now this was just a review from that chapter we talked about factoring. Imagine if we have something like this. Definitely we can from right hand side go to the left hand side and write it like a complete square, correct? But let's say instead of x squared minus 10x plus 25, I had plus 2n. So you know that this one was x squared. This one is 2 times x multiplied 5. Now after solving this should be 5 squared, but it is not 5 squared, correct? So it's missing 5 digits, 5 number. If we add 5 to this, we would easily convert it to this form, right? So completing a square, this method shows us how to add or subtract some of missing numbers to reach this point and make a complete square. So most of equations we see from now on, they are not perfect like this. There is something missing, and we should cover that to make a complete square on the other side. So it says, let's say now we have a formula like this. A plus d power 2 equal to x squared plus 2dx plus d squared, which is exact same as this one. Just instead of a we put x, instead of b we have d, correct? So there is not that much of change or difference. So let me give one of these examples. Let's say if we have x squared plus 6x plus 8, compare it with that top part. This should be 2d, right? And this should be d squared. If we have the form like x squared plus 2dx plus d squared, we could write it down in this form, right? So our aim is to reach this, but let's see if we can reach this or not. This one is 2d. So what is d? D is equal to 3. Am I right? So 2d is 6. So d is equal to 3. This one then should be d squared, which is 3 squared, which is 9. But it is not, right? So what we do? I know d squared, I know from here, d squared is 9. So I need 9 for this equality, for this equation. So I can what is that? I can make it a complete square. So what I do, I will add a 9 here. Then I put all of this together, x squared plus 6x plus 9 plus 8. Then this would be a complete square, right? But this is all the process, but in a real examples, we always have an equality, like we have equal to 0, for example, right? We have equal to 0 here. It doesn't make sense if we add 9 to just one side of this equality, correct? If we want to add anything, because this is equality, we have to add that number to both sides, right? So if you add 9 to this side, you had to add 9 to the other side and keep it like this. So now this one becomes x plus d, and you know d is 3, correct? And then let's keep other numbers that we have everywhere. So how we solve this? Just now we learned that if, for example, I have this thing, power 2 equal to some number, I can say x plus 3 is equal to positive, negative, radical 8, right? Just 5 minutes ago we had such a formula. I said, let's say this one is u squared is a, so u is equal to positive, negative, radical 8, right? So in order to have this form, we should bring all the constant to the other side. So the next step, we are going to bring 8 to the other side. So we have 9 minus 8. That was just a 0 and I ignored that. Doesn't matter. So from here, the next step, just simplify and combine these two. We have x plus 3 equal 9, power 2 equal 9, right? So now imagine, this one is u, this one is a. And u is equal to plus minus radical a. So from here, x plus 3 is equal to plus and minus radical 1. Correct? X plus 3 is equal to plus minus radical 1 is always 1, right? X is equal to, let's bring this to the other side. We have plus minus 1 minus 3. So there are two answers for x here now. One answer says, let's use positive 1. Another answer says, let's use negative 1. 1 minus 3 is negative 2. Negative 1 minus negative 3 is negative 4. This is kind of such a long process, but still, if you solve 2-3 more questions, you will understand exactly what we are doing. I should make up my own example. Let's say we have x squared plus 8x plus 10 equal to 0. I want to solve this using the method completing a square. Okay, the first step, we will find D. So imagine, this one is 2D, exactly like this. So what would be D? D equal to 4. So if D is equal to 4 here, we should have plus 16, right? But we don't have 16. So what we do? We add 16 to both sides of this equality. So D is 4, D squared is 16. So I will have x squared plus 8x plus 10 plus 16 on the both sides. Because this is equality, whatever you add on one side, you should have that on the other side too, right? You need this one and this one all together. Put them together. X squared plus 8x plus 16 plus 10 equal to 16. Now we know this one. This one is x plus d, which is 4 power 2. X plus d power 2. Correct? And the rest of numbers 10, 16. Now we should isolate this parenthesis and say x plus 4 power 2 is equal to 16 minus 10. So x plus 4 power 2 is 6. Correct? So now, imagine we have U, A. From here, U is equal to plus minus radical A. So whatever we have inside the parenthesis is equal to positive minus radical A. Correct? X is equal to 4 goes to the other side, becomes negative 4 plus and minus radical 6. Then one time x can be negative 4 plus radical 6, another time negative 4 minus radical 6.
So those would be our answers.
Yes.
Hidden.
So now we just talked about plus signs. X plus d. And this becomes plus. Well, what about negative signs? So if it was x minus d, this would be x squared minus 2d, right? So all the numbers we saw so far in these two questions, we had plus sign here, right? And then that's why we had x plus d at the end. Well, let's say now we have negative sign. We have x squared minus 6x plus 1 equal to 0. We want to solve this using this method, completing a square. Okay, so this one is x squared. This one should be 2d, right? 2d. If 6 is 2d, d is equal to 3. Exactly. If d is equal to 3, d square is 9. So we should have 9 here, but we don't have. So what we do? We add 9 to both sides, correct? So we will have x squared minus 6x plus 9 right? So now x squared minus 6x plus 9 is actually minus 6x. So this one will be x minus d, because we have a negative sign here, right? Previously we would say x plus d, but just because we have a negative sign, we are using a minus b. So that's why we have minus 2 times ab. So it becomes x minus d, which is 3 power 2 plus 1 equal 9. Right? So now x minus 3 power 2 is equal to 9 minus 1.
Why did you put 9 minus 1? Oh wait, just saying.
So 1 goes to that. X minus 3 power 2 is equal to 8. Now we should solve this. X minus 3 power 2 is 8. X minus 3 is positive minus radical 8. Is that correct?
Yeah. Can I just simplify radical 8 after
Exactly. I wanted to just ask you. So what is radical 8?
2 radical 2.
Exactly. Correct? Radical 8 is 2 radical 2. So we have x minus 3 equal to positive minus 2 radical 2. And then still we should bring this to the other side, right? So x is equal to plus minus 2 radical 2 plus 3. So one answer is 2 radical 2 plus 3. Another answer is negative 2 radical 2 plus 3. And actually, if I rearrange them in this form, it would be more beautiful. 3 minus 2 radical 2.
Could it go either way?
Yes. Do you have any question so far? So one more example using the completing a square. We have 3x squared minus 8x plus 1 equal to 0. It seems we cannot use that, but what if you divide all these numbers, all these terms, by the leading coefficient, which is 3? So if we divide all of them by 3, we will have x squared minus 8 over 3x plus 1 over 3 equals 0. Right? This is a little bit more difficult than previous one. But as long as you know what we did before, you definitely can understand it. So we have this form and we want to use completing a square, right? So this number here should be 2D. Okay? So let's solve this. If 2D is 8 over 3, D is equal to 16. Look, you want to solve for D, right? You divide both sides by 2. So it will be 8 divided by
2.
8 divided by 2 multiplied 3. 6. 8 divided by 6. But still, before even multiplying, I could simplify this to what? 4 over 3, right? 8 is 2 multiplied 4. This one is 2 multiplied 3. 2 multiplies to 4. 2 multiplies to 3. What remains? 4 over 3. Correct? So what happened here? We know the midterm here should be 2D, and we wanted to find D. Solving this, we found D to be 4 over 3, right? So D is 4 over 3. And then the next step was checking to see if this one is D squared. So the D squared is 16 over 9. Am I right? But this one is not 16 over 9. Okay? So we will add D squared to both sides of this equation, like previous example. We add 9 to both sides, right? 9 was D squared. Here also we have D squared. We add this D squared to both sides. So we will have x squared minus 8 over 3x plus 16 over 9 plus 1 over 3 is equal to 16 over 9. Am I correct? So you will definitely know what is this one. This one is x minus d power 2, right? And you already know what is d. D is 4 over 3. Am I right? Okay, so let's write it down. X minus 4 over 3 power 2 plus 1 over 3 equal to 16 over 9. And we have to solve this now. Okay, so let me write it down here. So, we should isolate this parenthesis one side, right? So we should bring this to the other side, correct? So we will have x minus 4 over 3 power 2 equal to 16 over 9 minus 1 over 3. Now let's solve 16 over 9 minus 1 over 3. What is the common denominator? 9. Correct. 9 is correct, right? Is that? No. Is that? Yes. So 9 is common denominator. So from the first fraction, we don't have to multiply to anything because common denominator is exactly same as the denominator of this fraction. But the second one, we have to multiply 3 because 3 is missing from common denominator. So both of them will multiply to 3. So we will have 13 over 9. Correct or not? So we will have x minus 4 over 3 power 2 equal to 13 over 9. Let's say this one is u power 2, this one is a. So we will have x minus 4 over 3 equal to positive negative 13 over 9. So what you should do, bring this to the other side. So x is equal to 4 over 3 plus and minus radical 13 over 9. So let me show you one thing. So radical 13 over 9 here is equal to radical 13 over radical 9. Am I right? So radical 13 over what? 3. So radical 13 over 3. So we should write down x equal 4 over 3 plus and minus radical 13 over 3. They have a common denominator, right? We can combine them. And we can say, okay, denominator is the same. 4 plus and minus radical 13. Okay? If we want to continue, we can write down one answer is 4 plus radical 13 over 3. Another answer is 4 minus radical 13 over 3. Okay, so this method was completing a square, right? I guess this is the most difficult one, torturing one. There is an easier method. We call that quadratic formula, using quadratic formula to solve this kind of question. And that is much easier because you easily use a formula and solve it. Like this question. So one time we solved it with completing a square, right? Now let's solve it with using quadratic formula. Quadratic formula says if you have ax squared plus bx plus c equals 0, if you have such a form, x can be negative b plus minus radical b squared minus 4 times ac divided by 2a. This is a formula for quadratic formula. Okay, so now let's say this one is A, this one is B, this one is C. Just replace this number, all these numbers in this quadratic formula, and you will get answers for x. X is equal to minus b plus minus radical b squared minus 4ac divided by 2a. Now replace everything. You will have negative 8, because 8 is negative, 8 is b, right? Plus and minus radical, again we have b, but this time b squared minus 4 times a is 3, c is 1, divide by 2 multiplies to 3. Just replace all the numbers you have. So you have negative multiply negative is positive 8, right? Plus minus radical 16, 8 is 64, minus 12 divide by 6. Right? So 64 minus 12 is
58 or 52.
52. Divide by 6. 52 is 13 multiplies to 4. 52 is 13 multiplies to 4. I want to just simplify this. Okay, so let's continue here. 8 plus and minus 13 multiplies to 4, divide by 6. 4 comes out, right? Because this is radical, 13 multiplies radical 4. So we have 8 plus and minus 4 radical 13 divided by 6. Correct? Because this is 13 multiplies 4. 2. Now it's correct, right? 4 comes out, radical 4 is 2. Well, still we can simplify more. Because 8 is 4 multiplies to 2. So I will bring out 2. 4 remains, plus and minus radical 13. Divide by, we know that 6 is 2 multiplies to 3. correct? Then what is canceling here? This one cancels with this one. The final answer is 4 plus and minus radical 13 divided by 3. So we found this answer using quadratic formula. We found this answer using completing a square, and the answers are exact same, right? Here also we have two answers. 4 plus radical 13 divided by 3, 4 minus radical 13 divided by 3. So we used two different methods to answer this. One was completing a square, another is quadratic formula. Okay, this one. X squared plus 8x equal to negative 3, and ax squared plus bx plus c equals 0 is x equal to negative b plus minus radical b squared minus 4 times ac divided by 2a. Okay, so find a, find B, find C, and replace everything. So in order to find them, you should rearrange this and make it in this form, right? So this one goes to the other side, and then coefficient of x is 1, right? So A is 1, B is 8, C is positive 3. So am I right? X is equal to positive, negative, negative 8 plus minus radical b squared is 68 minus 4 times a multiplies to 3 divided by 2. Oops, what I wrote down here, 60. This is the second time so I write 6. Okay, negative 8 plus minus radical. Again 52. Okay, divide by 2, right? Equal to negative 8 plus minus 52 was 13 multiplies to 4, right? So that becomes 2 radical 13 divided by 2. Am I right? And then we have negative 4 plus minus radical 13. 2 will cancel. solve this one. 2x squared minus 48. Two x squared minus 48 equals 0. What is a? 2. What is c?
48.
Negative 48. What is b?
0.
Exactly, 0. Okay? So x is equal to negative 0 plus minus radical 0 minus 4 times 2 multiplies to negative 48. 4 times AC. Divide by 2 multiplies to 2 equal to plus and minus, don't forget this, radical. This becomes positive. Am I right? 384?
48 times 4.
Oh, actually, 48 multiplies.
Isn't it negative?
Positive. Right?
Yeah.
Well, why we did that? Because we want to simplify this, huh? So it was 4 multiplies to 2 multiplies to 48, right? 4 comes out. And then 48 also is 24 multiplies to 2, 12 multiplies to 4, 4 power 2 multiplies to 3, okay, 4 power 2 multiplies to 3, 3 multiplies to 4 power 2. This is all we have under a square root, right? 48, we solved 48 5, 6 times so far. 48 is 4 power 2 multiplies to 3. Okay, so what comes out? 4 becomes 2. This 4 power 2 comes out. 2 and 3 stays in the radical. This one cancels with this one. 2 radical, 6. Correct. Do you have any question? So still, I'm not done with this chapter. There are many things we should talk about in this chapter. Okay? Any question? Anything? Okay, so our class is until 1:45, yes? Okay. So if you don't have any question, we'll see you on Wednesday. We continue chapter 8. Huh? It's wrong? Oh, I'm sorry. Yeah. No, I tried to copy paste, but probably I missed something.
It's okay.